So that's absolutely essential for life, because if you live in a pond and it freezes over, that actually protects everything below it and insulates it. And most liquids would freeze from the bottom up. But water, since ice floats, it freezes at the top, and then that insulates the rest of the liquid water, maintaining liquid water throughout the entire winter. And that way fish survive it. So very, very few materials are denser as liquids and solids. Typically a solid is usually denser than a liquid. But water and bismuth, the element, both of them have denser liquids than solids, which gives them some unusual properties. And again, water's high boiling point, its high heat of fusion and vaporization, and the fact that ice floats is all due to hydrogen bonding. So the structure of water. From VSEPR theory, we'd predict that the hydrogens would be 109.5 degrees away from each other. In reality, they're 105 degrees apart. Lone pairs take up a little bit more space than bonds to atoms. And so because there's two lone pairs, these two hydrogens get scrunched together a little bit, and they're about 4.5 degrees closer together than you would have anticipated just from the theory. Water has a permanent dipole due to the water molecule shape. And again, oxygen had an electronegativity of 3.5. Hydrogen has an electronegativity of 2.1. There's a 1.4 difference, which makes it a dipole, because it's 0.5 or greater. So you have a permanent partial negative and a permanent partial positive, which makes water an excellent solvent, because these negatives and positives are really useful in dissolving other ionic compounds. So they call water the universal solvent because it dissolves most things. Sources for human consumption. In the United States, we are very fortunate that America has a lot of water. Not every region. We do have desert regions in the Southwest that have huge water shortages sometimes. But overall, the country actually has a lot of water. Whereas water is in very short supply in a lot of places on the globe. Strategies to sustain water supplies. You can reclaim wastewater. And so once water goes through a sewage system, it gets reprocessed, chlorinated, and sent back out. And you reuse it. You can desalinate seawater, but that's extremely expensive. So it's typically done by oil-rich countries that have a lot of fuel to burn. And so oil-rich countries are able to take ocean water and distill it basically into fresh drinking water. And that works if you have the money to do it, or the oil to do it. So that's typically done in the Gulf states. Low temperature distillation, to use less energy to boil the water. The combustion of hydrogen is, we look at more and more renewable fuel sources. A big question is, how do you make solar power work all the time, all year long? And the question is that because sometimes the sun's not shining. So when the sun is shining, you have to be able to store energy up that you can use when the sun's not shining. And a big push in that technology is hydrogen gas. When the sun is shining, you can use the extra electricity to hydrolyze water into hydrogen and oxygen. And then when the sun's not shining, you can burn that hydrogen and you just get water back. It's the only waste product. And so you get that energy back. And so one day when we do cycle completely to solar power, that's going to be a key intermediate, that during sunny times and sunny seasons, you can make a lot of hydrogen gas, which you can then burn when you don't have enough sunlight coming in. Even today, the technology exists. We could go completely solar. It would just be more expensive than burning fossil fuels. And so really it's an economics question. Like with the electric cars out today, once gasoline hits $5 a gallon, it's more economical to drive an electric car than a gasoline-powered car. However, gas is not $5 a gallon. Gas is like $2.60 a gallon right now, which means it makes sense to drive gas-powered cars still. And so at some point when we get close to running out of fossil fuels and the prices go up, you will have that inversion where all of a sudden the other technology becomes more affordable, and then people start adopting. You'll always have early adopters who grab on a technology at the very beginning because they think it's cool and they like it and they want to push it. But your mass amount of people will typically switch over technologies when it financially makes sense to do so. And that'll happen at some point. Osmosis. This is the process by which water flows through a membrane from a region of more pure water to a region of less pure water. Osmosis is like diffusion, but you look at it from the viewpoint of water. How is the water moving? And water wants to move from high water to low water. Everything moves from high to low. And so the water will go into this raisin until it reconstitutes into a grape. But osmosis is just diffusion from the perspective of water. How will the water move? And the water will always move from a higher concentration of water to a lower concentration of water, which is why drinking ocean water can kill a person. Because you take a big gulp of seawater, now the liquid in your stomach is saltier than the rest of your body, which means the rest of your body's tissues, the liquid is more watery than that salt water, which means that water is pulled out of your cells and goes into your stomach to neutralize the salt water until it brings the salinity down to your body's salinity, and then a person will pee it out. And so as you keep drinking salt water, you keep dehydrating more and more as this osmotic reaction occurs in the body. They also use it for medicine. Before someone gets like a colonoscopy or something, they drink this huge thing of Golightly solution, but it's a pegylated solution, which just makes a huge osmotic pressure difference, and so liquid just starts pouring into your intestines from your body, and so it washes and cleans everything off, so then doctors can put a camera up and pretty much view the whole thing. But it's the same principle at play. Reverse osmosis is applying pressure to a solution to push it across a semi-permeable membrane and to get pure water out of it. A semi-permeable membrane is one that only allows the water to go through and not the salts. And so ships typically have an emergency one of these on board in case they get shipwrecked. You put ocean water in, it applies pressure, and it pushes the fresh water through the filter. These are best used for emergency situations because the filters have to be changed often for them to keep working well. And that is the end of chapter 13. Any questions? Questions at all? All right.